Welcome to Evil Dojo, Project Euler, problem 11, largest product in a grid. In the 20 by 20 grid below, 4 numbers along a diagonal line have been marked in red. 1, 2, 3, 4. The product of these numbers is 26 by 63 by 78 by 14, which is 1788696. What is the greatest product of 4 adjacent numbers in the same direction, up, down, left, right, or diagonally, in the 20 by 20 grid? Something that would be smart to do for this one. Save this to a file. So now we need to read that input. Let me disable Copilot before I forget. So we're going to go and open the file and close the file. And then we don't have a buffer that we read into. So when something like scanf, right? So scanf will return the number of input items or 0 in the event of an early matching failure, and EOF if we reach an end of input. So So we're reading in numbers, right? And they're 2-digit numbers. For 1, 2, 3, 4. 5, 6, 7, 8. This is really inefficient. So while, let's see, oh, whoops, that needs to be the address symbol. So we're going to start in column 0. So we're going to read in a number, and then we're going to have a row as well. And we want a matrix of 20 by 20. Matrix of row, column, equals number, and then we want to increment column, and if column is exactly equal to 20, then row plus plus and column equals 0. And if row exactly equal to 20, then we break out of the loop. While we're here, let's print the number. And if we read in a row, then we're going to print and go to the next line. So there's our input matrix, right? Like, we've reproduced it, so we're pretty confident that it's a one-to-one, so we can actually do real computations on it now. We're going to need a function that, given a position such as 0, 0, right? We're going to start up here. We're going to take a block from here to here, here to here, here to here, here to here, and perform the product on each column in that block, each row in that block, and the two diagonals. And then out of that, we want to find the greatest product out of those and return that. So we're going to have a double pointer to matrix. We're going to have an int like I, or rather int row and int column. We're going to make the assumption that we're not going to call this on any positions that are invalid, right? So no real error protection here. But let's do an example. So unsigned long int product equals 1. So we would say product times equals matrix of row and column, and then so really this would just be one product, right? So this would compute one product of one column. All right, so those are the products for like each row. Now we need to do it for each column. So for instance, plus 0, plus 1, plus 2, plus 3. So this would be for just column plus 0. So we do 5, 6, 7. 4, 5, 6, 7. 5, 6, 7. This is like really brute force. It's to prove a point, though. So what about the diagonals, right? So let's take so like for instance, we take the top left, which would be 0, 0. Do 1, 1, we do 2, 2, and then 3, 3. And then we'd also have to go in the opposite direction. So we'd have to do 0, 3. 1, 2, 2, 1, and then 3, 0. Now, we have one major problem. How do we compute the largest number? So we could do vector of unsigned long int nums, and then we could do nums dot push back product 0. So now we have our numbers in a vector, so they're easy and nice to manage, rather than having to deal with all these different variables. Now we can have unsigned long int largest, and then for auto in nums, if n is greater than largest equals n, and then we just return largest. So if we go through every position or every block starting from here, and we do every single possible block, then out of this process we should get the largest. Because if we take the largest from every block and then take the largest out of those, we should get the final result. So this reads it in. Let's do an example. Greatest product in block. It's right here, greatest product in block. Oh. Whoops. What if I passed it as the address? No, that won't work. How about we do shit. It isn't like that. How about we just push the whole matrix in? Okay, I like that. Oh, that's a big ass product. That don't seem right. That don't seem right at all. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it's printing out a way bigger number. What the hell? What the actual hell? So why would it be printing such an arbitrarily huge number? When none of those products are anywhere remotely close, right? So 8 times 49 times 81 times 52. There's that one right here. So let's do 8 times 2 times 22 times 97. 34144. Okay. Oh wow, it's actually running through the whole thing and not finding a new largest because, oh, I'm a fucking idiot. Okay, that looks better. So if we run through and actually j is less than 16, 17, because we want it to hit 16 to do 16, 17, 18, and 19. But when it hits 17, we want to move on to the one below it. Alright, so this appears to be the largest out of all of them. Let's try it out. Fucking right on the first try, god damn.